Hi, my name is Dean Passion, and I am the Director of Advanced Programs at First RF Corporation. The Navy has asked our company to find a way to develop a multiple beam, active, digital phased array antenna for use on ships. We developed a modular and scalable version of this phased array that can be used on surface ships, but based on its modular design, it can also be scaled up or down in size to meet the needs of other platforms. First RF is a 20-year-old small business that develops antennas and RF systems. In the first year of operation, we set the single-year record for the number of SBIR wins. We're most well known for the development and production of the antennas that helped save our service members' lives in Afghanistan and Iraq by jamming the remote operation of improvised explosive devices, or IEDs as they are generally known. The invention behind that 300-to-1 bandwidth antenna received the Army's Top 10 Inventions of the Year award, and these crew antennas went from a Phase 1 SBIR directly to production. First RF has produced over 250,000 antennas in our facilities in Boulder, Colorado. With the proliferation of greater numbers of manned and unmanned sensors and platforms, there are increasing needs for data exchange between these platforms. A multiple beam, electronically steered digital phased array antenna offers the potential to meet these increasing communication and data link needs. Antenna solutions should be scalable for accommodation on large and small platforms. Since there may be multiple communication links at both short and long ranges, the antenna and the resulting communication systems need very high dynamic range. Electronically steered phased array antennas are the key to meeting the need for directional antennas with the ability to quickly repoint the beam for ad hoc networking and also for dynamic movements from ship and the motion of the destination node for the link. In addition, modern communication links should be higher in gain for very high data rates. And this means that the antenna beam is both directional and narrow in its field of view. Directional antenna beams have better LPI/LPD performance just by that narrow beam width, and active digital phased array antennas can mitigate intentional and non-intentional interference by forming nulls in the radiation pattern. As already mentioned, the system needs very high dynamic range to allow operation with close nodes without blocking access to the nodes at the greater ranges. First RF is using a novel phased array antenna construction approach. The building block is called a simple manufacturable array technology, or SMART card. And this SMART card contains multiple antenna radiators or elements, along with amplifiers, phase shifters, and control electronics that form the basis of an active electronically scanned array, or AESA antenna. A chassis or enclosure is built to accommodate multiple SMART cards. Each SMART card gets an address from the chassis location to allow for the distributed computation of the settings of each card during operation. The master controller only sends pointing commands for the array, and each card then performs its own calculations in parallel with all of the other cards. The SMART cards are interchangeable, and any card can be placed in any slot in the enclosure. The modularity isn't only within a single chassis, as multiple enclosures will be used for 360-degree coverage, and in larger arrays, multiple enclosures may be used for each face of the antenna array. There is good history in the smart card approach to building modular phased arrays, which can be easily scaled to any size. Many different AESAs at First RF use this construction method, and many First RF antenna arrays using smart cards in their fabrication have thousands of hours of operation. I'm sure that many of you are familiar with the typical SBIR or SBIR program progression. We developed this modular and scalable phased array concept in phase 1, and we're working to build and test prototype hardware during our current phase 2 effort. Based on strong interest with our sponsor, PEO IWS 6, the progression beyond the basic phase 2 effort appears likely. We have already talked about the scalable design using the modularity of the smart card construction. We have not, however, spent much time on the many benefits of AESA hardware for these types of communication relays. A higher gain antenna with a directional beam is the key to high data rates, but a directional antenna needs to be pointed. The lower gain omnidirectional antennas that have been used in the early forms of UAV relays didn't need to be pointed because the beam goes everywhere. This new directional antenna provides extremely fast beam steering to quickly switch to a new node in the network, which is critical for ad hoc networking. But the fast steering is also used to compensate for the motion of airborne nodes, as well as the motion of the ship that hosts this active digital phased array antenna system. All surface vessels are potential hosts of this active phased array antenna solution, and smaller versions of this modular design could also be used on airborne platforms. This is actually a great place to ask for other transition opportunities. If you see a benefit to this type of active digital multiple beam phased array antenna system that supports very high data rates and is modular and scalable with very fast beam steering that meets the needs of dynamic platforms or for quick switching between nodes in a network, please let us know. While the size of an antenna is based more on physics than it is on technology, smaller antenna systems are always desired. To keep the performance up under any reduction in size, we use more efficient power amplifiers on transmit, lower noise figure amplifiers for receive, and low loss components for both parts of the link. While this application is for communication or data link relays on surface vessels, the market for these types of AESA antenna systems includes radar and other electromagnetic transmit or receive needs. These types of arrays can be used over a wide range of frequency bands, and while First RF is mostly focused on arrays from S-band up through millimeter wave bands, we have built phased arrays down through UHF and antennas all the way down to VLF, very low frequency, like 3 to 30 kilohertz. As the interfaces to AESA antennas become more standard, the modular and scalable solution of this program will also be more common. The legacy approach of starting each phased array antenna design from scratch will move to leveraging heavily from existing designs like you see here. Commercial communication systems have a need for directional antenna arrays, and this need is driven by both higher data rates and spectrum reuse issues. On the DoD side, there is a similar need for high data rates, but security is the driver for the directional beams, even though interference mitigation is another benefit. All uses will need quick beam steering for mobile platforms and ad hoc networking. I want to thank you for listening to this presentation, and I am happy to be able to talk about this innovative AESA antenna system, which supports communication relays at high data rates and over a very wide dynamic range. First RF is a small business with a tremendous ability to meet the toughest antenna challenges. Ian Rumsey or I will be happy to talk with you further about any opportunities to use these modular phased array antenna solutions to scale an active phased array antenna to meet your need.